Are we there, or did we already do this one? We did this one. Okay, they've actually found the zeros. Okay. Alright, so again, to find the zeros, we need to either be able to factor and then after that determine the multiplicity. So if you're left with a 4-term polynomial, you factor by grouping. Very good. Let's use red. So I'm going to group up the first two. Maybe. There we go. Okay, there we go. It's a little lag there. Okay, that's cool. All right, so factor by grouping up the first two and then the last two. What does the first two terms have in common? Nx squared. So we go x squared. What is left? Good, we have x plus 5 left. And then yes, the goal is for the two binomials to be the same. So since I have x plus 5 here, but negative x and negative 5, I want to factor out a negative 1, which will then change those signs. Eventually. All right. Once the binomials are the same, I'm able to factor out that binomial as one singular binomial. And then I can then write the factors that I took out, which is x squared minus 1. All right. From that point, you can then start solving them because once it's factored, you want to set those factors equal to 0. So I then get x plus 5 equals 0 and x squared minus 1 equals 0. And then how would I solve the first one? Minus 5, so I get x equals negative 5. How many times did I get that answer? Once. So that means my multiplicity is 1. All right. How would I solve this one? Plus 1, so I get x squared equals 1. Then I need to do the square root of that, but don't forget what? Plus or minus. And the square root of 1 is 1. So technically what I just got is I got x equals negative 1 and x equals positive 1. How many times did I get each one of those numbers? Just once. So the square here applied it so that I got a positive and negative 1. Had I had the square outside the parentheses, that would then tell me I got it more than once. So both of these have a multiplicity 1. No, there's 3 answers. Yeah. Correct. Yep. So those are the zeros. So my 0 is negative 5, negative 1, and 1. I don't remember if I talked about this yesterday or not, but the highest degree tells me my possible zeros. All right. So that means I will have at most 3 zeros. Doesn't mean I'm going to have 3 zeros. I'll have at most, which in this case, I have 3 of them. I can't have any more than that. All right. So we good there? All right. If one is already factored, just set each one equal to 0. So I take negative 2x to the 4th power, and I set it equal to 0. What's the first thing I would do? Divide by negative 2. And what's 0 divided by negative 2? 0. Then I would do what? I would quartic root it. Yeah, so technically it's just the 4th root. But what's the 4th root of 0? Just 0. So I get x equals 0. True, but those the same thing. What's the multiplicity though? That's the 0 is 0. Nope. So it's 4. So notice the difference between this one and this one. This had an x squared minus or plus a number. This was just negative 2x to the 4th power. All right. Then I'm going to take this guy right here, x plus 1 cubed. So I take x plus 1, set it equal to 0. What does x equal? Negative 1, right? Because you would do what? Subtract 1. But how many times did I get the answer? 3. So my multiplicity is 3. Then you would take the next factor, x minus 2, equal to 0. And what does x equal? 2, right? Because how would I solve it? Add 2, right? What's the multiplicity? 2. Which is 2. Very good. All right. Any questions on how to calculate zeros or calculate their multiplicity? Code? Yeah. Okay. All right. So let's look at objective 3, which is applying the intermediate volume theorem. What the intermediate volume theorem states is if I can plug in a value of A at one interval endpoint and get a number that's either positive or negative, and then plug in the other endpoint of the interval and get an opposite of a positive or negative, then at some point it had to be 0. So meaning, intermediate volume theorem states if I have an interval and I plug in those endpoints of my interval and one value is positive and one value is at negative, at some point it had to equal 0. That makes sense? Let me make it bigger. Yes, as long as the function is continuous. And we know all polynomial functions are continuous because it never picks up a pencil, right? So again, if I plug in a value and I get a negative number, and then I plug in the other endpoint and I get a positive number, at some point it had to hit 0. We don't know how many times, but we know it at least did it one time, right? If I plug it in and I get 2 positives or 2 negatives, I cannot determine if it ever did cross the 0. It might have, but I cannot determine that because it could just have been right on the bottom, stayed there. Right? So that's basically what the intermediate volume theorem states. I don't know. Yes. All right. Are we ready? All right, so they did the work for us. They gave us the table so that we could calculate it, just determine the answer. If you needed to do this by hand, you would literally take each interval and you would just plug it in to calculate what the answer is. But since they did this on the book, I'm assuming they're probably going to do it in the homework as well. All right, if they don't, again, all you have to do is just plug it in and just calculate. All right, so I'll give you an opportunity to write that down. Totally up to you. The only issue is I have to exit back out of it because I don't know if I'm able to write on it. Yeah, it won't let me write. I wonder if I can go into presentation mode and it'll do it. No. Yeah, so if you had to do it by hand and it did not supply a table for you, you would just basically take each interval number and plug it in to figure out if it's a positive or negative. This is not a multiple choice question. This is actually 4 parts. No. Well, maybe. Could be like a yes or no. Like, is this a function? Yes. Or no. True. What? Yes. So yeah, so I'd put no. So these are not coordinates, it's intervals. So you would plug in -4 in for x, get a number. Then you would plug -3 into x and get a number, and then see, did I get a positive and negative? Can I what? Can I zoom in? Is that better? Those are the new ones. Those go to the tested teachers first, or just dual credit. No. Mm-hmm. All right, are we ready? Oh. Yeah, you need a table. Without the table, like I said, you would have to do all the work and actually calculate what each number is. But my assumption, since it was given to you on in the textbook, I'm going to assume it's going to give it to you on the assignment. Haven't started it? When you say that, do you mean the very top or do you mean the top of the table? No. Are we ready? All right. So the way this works is super simple. What I'm going to do is I'm going to figure out what the y value is when x equals -4. So basically what I'm doing is I'm trying to figure out what is f of -4. So I go to -4 and it equals what value? 243. Which tells me, is that greater than or less than 0? It's greater than 0, right? So for the intermediate volume theorem to work, when I plug in -3, I need to get a number less than 0. So let's see if that happens. So I go and I now do f of -3. And when I go to it, what is the value? -44. Is that greater than or less than 0? It's less than 0. So as long as I get an endpoint that is greater than 0 and less than 0, then intermediate volume theorem does guarantee a function has a 0. Yes, as long as you have one that's greater, one that's less, then at some point it had to be 0. All right. So as we keep on going through this, we know f of -3 is what? -44, which is what? Less than 0. All right. So then when I plug in -2, it needs to be greater than 0. So f of -2 gives me 153. Very good. Is that greater than or less than 0? So therefore, does the intermediate volume theorem apply that the function has a 0? Yes. All right, let's keep going. So then we see f of -2. We already know it's 153. Is it greater than or less than 0? Greater than 0. Then we need to determine what f of -1 is. We need to see, is it less than 0? We look at it and we see that it's 360. So that's greater than 0. So therefore, I have two things that are greater than 0. So therefore, we cannot guarantee that the function has a 0. It might, but we cannot guarantee it. No, this is as easy as it gets. So then we got f of -1. Again, we just saw it was 360, which is greater than or less than 0. Greater than. And then we need to plug in f of 0. And I'm looking to see if it is less than 0. And we see that's 343, which is greater than 0, which is not less than 0. So therefore, does the intermediate theorem guarantee the function has 0? No. So questions on how to apply the intermediate volume theorem. Pretty straightforward. All righty. Objective 4 now is to sketch a polynomial function. Yes. I would say you could probably put it on the bottom of it. You might be able to fit it there. You'd be good. Maybe. Yeah, maybe. The first thing you need to know in objective 4 is turning points. I kind of got ahead of this at the beginning of today's lesson when I said possible zeros. So to find your possible turning points, you take the highest degree minus 1. So if my highest degree is 4, then I have 3 possible turning points. If my highest degree is 3, then I have a possible 2 turning points. Yes, make sure it's in order. You look for the highest degree minus 1 tells you the number of possible turning points. Doesn't mean that's how many times the directions will change, just how many could change. Are you ready? All right, so you don't have to write this word for word, but to graph a polynomial function, here is a little bit of a procedure. And you can find this, of course, in your textbook. I could. Um, so first thing you want to do is you want to use the leading term to determine what the end behavior is. So that's where you look at the highest degree, see if it's even or odd, and then look at the coefficient, see if it's positive or negative. See how the function starts and ends. All right, that's step one. Step two, determine your y-intercepts. Those are the super easy ones. That's where we literally just let x be a 0. That gives us another point on the graph. Step three, determine the real 0. So then we will factor our problem out, set those equal to 0, and determine where it crosses the x-axis with the applied multiplicities, knowing that if the multiplicity is even, it will touch the x-axis and bounce back up or down. And if the multiplicity is odd, it'll go through it. Okay. And then, of course, after we get all of our results, we will then graph those points. We will then start sketching the graph. We'll start at one of the end behaviors and then travel towards the smallest x-intercept or the 0, determine if we need to go through it or bounce up and down, and then keep going until we get to the end behavior. As of right now, the only thing you don't know how to do is determine the extremas. Okay, but we're not looking too hard in that. So again, we'll sketch the graph. You could use this to plot other points, but we don't really need to go through the whole symmetry thing. And the more points you do plot, the greater accuracy you have. So I will show you. You know what? I'm gonna go ahead and show you how you can calculate the extremis, just so you have a more accurate graph. All right. All right. Does everyone have this written down or a picture of it or whatever? Oh, since it was the easiest thing, you would just plug in 0 in for x, and then I can easily get my y-intercept. So the more points we get, the more accurate we can be, and then I'm about to kind of explain how you can easily find the extremis. All right, do we all have it? Or at least what we want of it? All right, so let's sketch this guy. All right. So let me draw me a little graph. Okay. So step one was what? Okay, hopefully the graph will be supplied for you. No, not yet. Find the leading term so we can know how the end behavior is. What's my leading term? X to the fifth, right? So I'm just going to pay attention to this part right now. So my 5 being my highest degree. Good, so therefore it's odd. And then the leading coefficient, is it positive or negative? Positive. So odd, the graph will either go like this or like this. So if it's odd positive, which direction do I have? Goes like this. Think of it like as the x cubed. So therefore, my end behavior will start at the bottom and finish on the top. Okay, so that's what I know. All right. So the way I like to then come over here to my main graph is I'm just going to have a little arrow on the bottom there and an arrow at the top there. So this is where I will start when I start making my graph. This is where I need to end. If I don't end on this side, then I messed up somewhere in my zeros and I messed up on my multiplicities. All right, so that's going to be a good check for you. All right, what was step 2 then? That was y-intercepts, wasn't it? Yeah. Yes, ma'am. I don't. That's why I took off after 5th. I did click like no sub, didn't I? Oh, I got you. Yes, ma'am. You're welcome. Yes. So if I plug in 0 for x, so I'm trying to determine my y-intercept because that's a nice, easy point. So that's g of 0. And if I plug in 0 in for all of my x's, what do I get? 0. So that means I have a y-intercept at 0. Right, so that gives me a point on the graph. What was step 3? Find the zeros. It's not in factored form, so I need to factor it. All right. So when I look at x to the 5th minus 2x to the 4th, when I go to factor, what's my number one question? Greatest common factor. What's my greatest common factor here? X to the 4th. And then I'm left with what? Now that I have my factors, what do I do with those factors? Set them equal to 0. So x to the 4th equal to 0 will give me x equals what? 0. With a multiplicity of what? X minus 2 equals 0 will give me a 0 of what? Of 2 with a multiplicity of what? All right. So now I'm going to graph those x-intercepts. Already have one at 0, which makes sense. If it crosses the 0, it's an x and a y-intercept. But then I also have one at 2. So I come over here. And I have a point at, there we go, a point at 2. All right, so far that's what I got so far. They're kind of coming together. What was step 4? Okay, we did that. Step 5? There was something before that. So we want to draw and sketch. Then we want to find more estimates. All right. So when I'm sketching this graph, I want to start from the beginning and then go to my next 0. Okay. When I do that, at this 0, what is the multiplicity? Is it even or odd? All right. So since this is even, will it go through it or touch it? It will just touch it. All right, so what that means is I will travel towards the 0 and then I will just touch it and bounce back down. All right. Then when I get to 2, at some point I got to bounce back up and then I got to go to the 2. What's going to happen when I get to the 2? I'm going to go through it. Why? Good, because the multiplicity of 2 is odd. So therefore I go through it. So at some point I'm going to bounce back through and I'm going to go through it and I'm going to finish up at my end behavior. Now, here's where it gets fun on trying to determine where the extrema is. Polynomial functions are symmetrical between zeros. So if I want to know where my extrema goes, just choose the x value that is between 0 and 2. What 0 or what x value is between 0 and 2? It's 1. But you want to be dead